So what we're going to do today is some key features of quadratic functions. Let me just focus a little bit better. So up top here in your notes, you'll see some helpful hints on how to find these different key features of quadratics. We're going to go through a standard form, a vertex form, and a factored form and figure out how to find all of these things. So I'm going to do all of this through graphing, which hopefully by now you feel pretty comfortable with. So since this is standard form, one thing I can start with is the y-intercept. I'm also going to find the axis of symmetry. So for that, I know that x is equal to negative b, so negative 2, divided by 2 times a, which is negative 1. So this will be negative 2 divided by negative 2, which is 1. So here my axis of symmetry is at x equals 1. I know because a is negative, this graph is going to be reflected, so it will open down. So that means for this graph, I'm going to have a maximum. So then now I want to figure out the rest of my vertex point. So I'm going to substitute in 1 wherever I see x. So this is going to end up being 1 times negative 1. So negative 1 plus 2 plus 3, which is going to turn out to be 4. So I can reflect this point over here. Now, if you think about the change that we see in a quadratic function from my vertex, as long as a is 1, I'm going to go over 1 and down 1, and then over 1 and down 3. So this is also actually super helpful because it's going to help me find my x-intercepts. So again, if you're thinking about this in a table, I'm going to put my vertex in the middle. So this was 1, 4. My y-intercept is 0, 3. And then I also found, okay, so these are the x values I found. So because of symmetry, I know this is going to also be 3. Now these changes are both 1, whether it was -1 or +1. This would be minus. So this next change has to be 3. So this I'm going to go down 3, so that would be 0. Here I would have gone up 3, so that would also be 0. So I'm looking at that first difference here in my table. I can also do that first difference here on my graph. Just a reminder about graphing for your brains. All right, so this is our function. So now I'm going to actually start doing all of these things up here. So our range is always y values, and it's always based off of my vertex. If I have a maximum, which I do now, it's all of the values that are at or below the y value of my maximum. So here I see that my maximum y value is 4. So it's all of the y values that are smaller than or equal to 4. I already have my axis of symmetry. We found that. Our vertex coordinate is 1, 4. We already found that. This point is a maximum because of this negative coefficient. I'm going to skip the intervals for just a minute, and I'm going to do my intercepts. So our x-intercepts are at -1, 0, and at 3, 0. My y-intercept is at 0, 3. So now I'm at the point where I'm going to do increasing and decreasing. So let me get a different color here really quick. So what you're doing when you're writing your increasing and your decreasing intervals is I'm telling the x values where my graph is going up if I move from left to right. It's always going to revolve around the x value for my axis of symmetry. So then I need to figure out these values to the left of that, if those numbers are going up in y or down in y. So if you pretend that you're a little ant and you're walking along this function from left to right, the first thing we're doing is going up. So this would be increasing. So then it's all of the x values that are smaller than 1. And in this case, we are not including x equals 1 because I am actually changing at this point from increasing to decreasing. So that x value is not included. So now I've gotten to my maximum. Now my little ant is going to continue walking, and this is where we are decreasing. So now it's all of the numbers that are bigger than 1 where my graph is decreasing. Now the best part about a quadratic is these two things right here, the increasing and decreasing interval that we just wrote, these are always going to be the opposite of each other. You'll notice for increasing, x is smaller than 1, and then for decreasing, x is greater than 1. Those are always going to be the opposite inequality sign because it's either increasing or decreasing because of that symmetric property. Some reasons that you might need to know this, you could be asked questions that, if we're firing a cannon, when is the cannon ascending or increasing in height? That would be your increasing interval. When is it descending? How long is it falling to the ground? That would be something that you would need your decreasing interval for. But today we are only going to work on the actual inequalities themselves and writing our range and all that fun stuff. So with my vertex form, I can automatically find, if I could spell, I can automatically find my vertex and my axis of symmetry. So here my vertex is -2, 8, which means my axis of symmetry is x equals -2. And again, because I see this -2, I know my graph is going to be opening down. I can also find my my y-intercept. If I substitute in 0 here, so if I had x equals 0, I'm going to have -2 times 0 plus 2 squared plus 8. Well, 0 plus 2 is 2, squared is 4, times -2 gives me -8, plus 8 gives me 0. Which is awesome because that's also an x-intercept. So I can reflect this and find my other x-intercept. And now I have everything I need to not only graph my quadratic, but also do all of the rest of the things that we need to do. So I'm going to go to range first. Range is the only key feature that deals with the y value itself. Since it's a maximum, again, it's going to be all the numbers that are smaller than that y value from my vertex. So my y-intercept is 0, 0. Didn't actually write that point. Our x-intercepts are -4, 0, and 0, 0. So now I need to do my increasing and decreasing again. Now these are going to be the opposite values of each other. They're going to deal with my axis of symmetry. So I know that they're both going to somehow be related to -2. And I need to figure out which side is increasing and which side is decreasing. So here, as I'm walking from left to right, this is increasing. So increasing is all of the smaller numbers, which means decreasing is all of the bigger numbers. So everything on this side, again, is decreasing. All right, last but not least, our factored form. So here I can find my x-intercepts pretty quickly. I'm going to take x minus 1 and set it equal to 0, and I'm going to take x plus 5 and set it equal to 0. So here I have x equals 1. Here I have x equals -5. So I'm going to have 1, 0, and -5, 0 as our intercepts. So 1, 0 is here, -5, 0 is here. To find our axis of symmetry, oops, that's not a 0, that's the letter. To find our axis of symmetry, I am going to find the midpoint or the middle of my two x-intercepts. There are 6 spaces between this, so I know I need to go over 1, 2, 3. So again, we happen to have our axis of symmetry at -2. In order to find my vertex, I'm going to substitute that into my original equation. So I'll have -2 minus 1 times -2 plus 5. So -2 minus 1 will give us -3. -2 plus 5 is going to give us +3, which is going to give us a y value of -9. So our vertex coordinate is -2, -9. Since we do have to find our y-intercept in this case, I'm going to go ahead and substitute in 0 for my x value. So I'll have 0 minus 1 times 0 plus 5. So that's -1 times 5, which tells me my y-intercept is at 0, -5. If you want to be more precise and more accurate, you can reflect that over that way. And now I'm going to do my best to actually make this look parabola-ish. All right, so in this case, my vertex is actually a minimum. So we're going to see how that's going to change our increasing and our decreasing intervals and our range. So with our range, that's the only time I deal with a y value. So now It's all of the numbers that are bigger than or equal to -9 because everything lives above that vertex. So now if I look at increasing and decreasing, we're dealing with that that x value of -2 from my axis of symmetry. So these are both still dealing with -2. Oops, I just realized you can't see what I'm doing. So now if I'm a little ant walking along my parabola, the first thing I'm doing is actually decreasing, and I'm going down to my vertex. So decreasing is now all of these numbers that are smaller than -2. And then once I get to my vertex, then I start increasing. So increasing is now all the numbers that are bigger than -2. So anytime I have a minimum, I always decrease first and then increase. Anytime I have a maximum, I increase first and decrease second.